2.7 is the inverse of a function okay. We have to talk about what it means to be one-to-one first, and then we're going to talk about how to find the inverse. Okay, so let's start with one-to-one. I'm going to give you two graphs to graph here. Graph on the left side of your paper somewhere. Graph. Oh man, that was terrible. Don't grab that. Ooh, better. Graph that one. Just a normal parabola. And then next to it, I want you to graph just the right side of that parabola. Now the one on the left, underneath it, I want you to write not 1, 2, 1. On the right side, I want you to write this one is 1, 2, 1. Does this look at all familiar to anything last year you learned about one-to-one? Do you know what the vertical line test is? What is the vertical line testing? If it's a function. There's a similar test called a horizontal line test, and that is testing for one-to-one. So this parabola, if I were to draw a vertical line, right, or a horizontal line through this parabola, I hit it more than once, correct? That's why it's not one-to-one. It fails a horizontal line test. It's still a function. Isn't this still a function? But it's not a one-to-one function. So it's not a one-to-one function, rather. Okay? But this one over here on the right, it passes the vertical line test, yes? And it passes the horizontal line test. So it is a function, and it is also one-to-one. So this is a one-to-one function. Okay? Now, why does it matter if a function is one-to-one or not one-to-one? I mean, it's not a huge deal. Okay? But this is the important thing about being one-to-one. The inverse of a 1-to-1 function is also a function. That's the important thing about a function being one-to-one. Okay. If a function is one-to-one and we find its inverse, that will also be a function. Okay? Just to clarify this a little bit, you guys, you see this function that I'm circling? If we were to find the inverse of this by switching the place of x and y, the graph would look like this. Okay? This red graph is the inverse of the black graph. What's the problem with that red graph? It's not a function. Okay? It wouldn't pass a vertical line test. But this one here, the one that's in black, just the right side, the inverse of this would look like that. Is that a function? Why is the inverse here a function? Because it passes the vertical line test, and because the original function is one-to-one. This original function is one-to-one, so its inverse is a function. Okay? Let's just do a couple of quick problems of practicing finding the inverse. Find the inverse y equals the square root of x plus 2 minus 7. What was the phrase you guys were telling me about how to find an inverse? You switch the place of x and y. If you haven't heard that before, write that down. You switch the place. Joe, remember to look at the review online, okay? We switch the place of x and y. Switch the place of x and y. So to do that, we're going to have x equals square root of y plus 2 minus 7. Now what do we do? Is that all? Is this the inverse? Are we done? So let's add another set of directions. We switch the place of x and y, but then we have to solve. Now we have to solve for y. Now you got to do things in the right order. You have to follow your solving equation techniques here. What do we do first? Add 7. So we have x plus 7 is equal to the square root of y plus 2. Now we get rid of the square root by squaring both sides entirely. So that's why I'm putting parentheses around the left side, because you have to square the whole term and not just separate. If you write x squared plus 7 squared, that's incorrect. You have to square it all at once. So we have parentheses x plus 7 squared equals y plus 2. Now what? Subtract 2 from both sides. Where do I subtract the 2 from? The outside of the parentheses, yeah. So we're going to have x plus 7 squared minus 2 is equal to y. Okay. What is this right here? How does this what's the relationship between this and what we started with? These are inverses. Inverses. Oh. You can leave it exactly like this. You don't have to multiply it together. Is that what you're asking?
Yeah.
Yeah, you don't have to multiply it together.
Did you say something?